Now here's the last lesson of control flow, that is recursion. Students often consider this as the very difficult topic in programming. But once you get the base condition and the logic behind how to solve the problem statement, it becomes much more interesting. So let us start. In this lesson, we would be learning what is recursion, what are recursive functions, types of recursion, an example to write a code to find factorial using recursion, and finally the concept of stack overflow. So what is a recursion? Recursion is a process in which a function calls itself directly or indirectly. This is known as recursion. And the corresponding function is known as recursive function. Using recursive algorithm, certain problems can be solved quite easily. The examples of recursion are Tower of Hanoi, that is considered as a game solved using programming, in-order, pre-order, post-order tree traverser, and DFS of graph. We would be learning more about them in data structures. Now there is a base condition required in recursion. What is base condition? In recursive program, the solution to the base case is provided and the solution of the bigger problem is expressed in terms of smaller problems. Now let us look at the types of recursion. There are two types of recursion. The first is direct recursion. When the function calls itself, it is known as direct recursion. Whereas, when function calls another function and that function calls the calling function, this is called as indirect recursion. For example, function A calls function B and again function B calls function A. This is the example of indirect recursion, whereas in direct recursion, function A calls function A from itself. Now, how the memory is allocated in recursion? When any function is called from main function, the memory is allocated to it on the stack. A recursive function calls itself, so the memory for a called function is allocated on the top of memory allocated to calling function. And different copy of variables is created for each function call. Now when the base condition is reached, the function returns its value to the function by whom it was called in a sequential manner. And the memory is deallocated and the process continues. Let us learn this in detail by looking at the example. Now how to calculate a factorial. We know that a factorial is the multiplication of the number and the factorial of the number minus 1. That is, let's say we consider n as 5. So the factorial of 5 can be written as 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So now factorial of 5 can be written as 5 into factorial of 4. Now here factorial of 4 can again be splitted into 4 into factorial of 3. So it gives 20 into factorial of 3. Now factorial of 3 can be again splitted as 3 into factorial of 3 minus 1, that is factorial of 2. It results in 60 into factorial of 2. We continue this process till we reach to 0 and we get the answer as 120. Now, how to write a code for factorial using recursion? That is, we need to write a function for factorial wherein we will multiply the number and we will again call the factorial function for n minus 1. Here's the code. Now what will be the base condition, that is a terminating condition? It would be if n becomes less than or equal to 1. As soon as n reaches 1, 1 will be returned as a value. But if n is greater than 1, then we will return the number multiplied by factorial of n minus 1. Now let's consider a simple example. We need to calculate a factorial of 3. So the function for factorial will be called from main. Now this function will be invoked. It will check whether 3 is less than or equal to 1. No. So it will jump into else part and it will return 3 into factorial of 3 minus 1, that is 2. Now for factorial of 2, again this function will be called and a new stack frame will be generated. Let us consider it diagrammatically. Here factorial of 3 is greater than 1. So statement return factorial of 2 into 3 will be executed. Now a new stack frame will be generated for factorial 2. Here 2 is greater than 1 So it will again return factorial of 1 star 2. A new stack frame will be generated for factorial of 1. Now 1 is greater than 1? No. So we have written the statement return 1. So 1 will be returned and this stack frame will be destroyed. Now the 1 will be returned here. So its value is 1. So 1 star 2 is 2. Now it will return 2. And this stack frame will eventually be destroyed. This stack frame has returned the value 2 from the function where it is called. So the factorial 2 has got the value 2. So 2 star 3 is 6. Again, the value of this function is 6 and it will be returned to the main function finally. Now what is stack overflow? If the base condition is not reached or if it is not defined, the problem of stack overflow may arise. Stack overflow is generally considered as an error because stack frames go on creating and it never stops. So the stacks get occupied and it is termed as stack overflow. The memory is exhausted by the stack frames of these function calls, resulting in the stack overflow error. Let's have a quick recap. The process in which function calls itself directly or indirectly is called recursion. The corresponding function is called recursive function. There are two types of recursion, direct recursion and indirect recursion. If the base condition is not used or not defined, then the stack overflow error may arise. Here's the end of this section. In the next coming section, we would be discussing what is an array, 1D arrays and multidimensional arrays.